Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. So I'll start by asking whether any of you found an appropriate point in the question stem to pause to make some kind of inference. Because you know that's what we like to do on long word problems. And what inference do you think you can make at that point? R sub I is a mathematical notation that many people won't be that familiar with, especially if they're not engineers, if they didn't do a lot of math in university. But what that represents is they're basically saying, look, we know that there are 5 rows, because they told us that in the very beginning. And now they're talking about row I. So what does it mean, row I? Knowing that there are a total of 5 rows, this is their way of saying, we're just going to use the letter I to represent which row we're talking about. So if we're talking about row 1, then in that case, I equals 1. So when I equals 1, Ri is row 1. When I equals 2, Ri is row 2, and so on. So what you see there in parentheses, where they're saying I is between 1 and 5 inclusive, it's not really telling us anything we didn't already know. It's just kind of them confirming that, yep, we know that there are 5 rows, and so I could be any integer between 1 and 5 inclusive, because there are 5 rows and I just represents which row we're talking about. So I think that you might have slightly misinterpreted that inequality there in the parentheses. It's not actually telling us anything about the amounts themselves, and it's not actually telling us anything about the arithmetic mean. It's just confirming for us that, yep, indeed, there are 5 rows, and we are going to use I as a placeholder for which row we're talking about. Still though, when I see the word average, parentheses, arithmetic mean, I feel the need to make some kind of inference, and I'll use the definition of average. Like if you open the dictionary under the word average, what will you see? How is average defined in English? Average is a ratio, and every ratio has a numerator and a denominator. Other ratios that we see a lot are speed, right? Speed is a ratio of distance to time. Miles per gallon is a ratio of how many miles you can travel for a number of gallons. And average is a ratio of the sum of a set to the number of terms in that set. So if they're defining Ri as the average of row I, how can we use the definition of average to make an inference here? Each row has 4 amounts. And if Ri is the average of those 4 amounts, then the sum of those 4 amounts is 4 Ri. How did we make that inference? We just used the definition of average from the dictionary. If we know from the dictionary that average is ratio of sum to number of terms, then if we multiply both sides by number of terms, what do we get? The product average multiplied by number of terms equals the sum. We know the number of terms in each row. It was given here. We know that the average is Ri for every row. So R1 for row 1, R2 for row 2, R3 for row 3, and so on. So the sum of each row is 4 Ri for that particular row. And by the way, it's not at all a terrible idea to pause earlier, say to pause here, and draw a 4x5 table to visualize what the Excel spreadsheet would look like. Or if you want to save time, instead of 4x5, make it a 2x3. It would be the same concept, just smaller. Although, I don't think it would save you that much time. I would probably just draw the 4x5. How long does that take? So we read on, the average of the amounts in column J, so we're going to use the lowercase j to represent the number, the column number, and lowercase I to represent the row number. So j is going to be somewhere between 1 and 4 because there are 4 columns. And we're told that the average of a column is Cj. So let's make a similar inference now for the sum of each column. Sum of row I equals 4Ri, and sum of column J is what? Because each column has 5 amounts. And if it would help you, I guess it would help most of you, quickly grab a pen and paper and create this spreadsheet. Draw 5 rows with 4 columns so that you can visualize it and you can see. On that drawing that you're creating, I would jot down to the left of each row R1, R2, R3, R4, R5 appropriately, and on top of each column C1, C2, C3, C4. So you can really see on your paper what this looks like.
How are you so confident that R1, for example, is not the total, is not the sum?
If you weren't as confident as me, that means that you read too fast. Because this sentence is literally telling me what Ri is. So I don't have to guess. This sentence isn't talking about individual cells. It's giving me the average of 4 cells. Which 4 cells? The top 4. You look at your drawing. Do you have a top row that has 4 cells? R1 is the average of those 4 cells. So if you were to add them together and divide by 4, you'd get R1. If you ever find yourself having to guess, then you missed something. And the reason I say this is because you said earlier that when you got to that pause, you guessed that there would be 5 of those amounts. Because you hadn't read the next sentence yet, so you just kind of made an assumption there. But you shouldn't have to make an assumption. So if you find yourself unsure about something or not confident about something, that probably means that you missed something because you're probably reading too fast. You didn't pause long enough to digest what you're reading. And by the way, the best way to digest that first line of text is to draw the spreadsheet on your paper. In other words, spend more time chewing before you swallow. I should follow my own advice because I eat like an animal. But on the GMAT, I chew really well before swallowing. So we paused, we made an inference, we paused again, we made an inference. And some of you might be thinking, man, how am I supposed to make such inferences in under 2 minutes? And if that's what you're thinking, that means that you need to keep practicing making inferences because it shouldn't take that long to make these inferences. And if it does take you too long to make these inferences, then this question is too hard for you at this point in time. And I think that maybe is okay because it is a hard question. And as a reminder to everyone, you don't have to get every question right on this test to do well. So if you can't get a question like this right, that's perfectly fine. Just don't waste time on it. And why would somebody waste time on this question? Because that person didn't try to make these inferences. He read as fast as he could to the question mark and then chased his own tail for 5 minutes afterwards, trying to make heads or tails of these statements. And that's what you want to avoid. So the bad thing that can happen to you in a question like this on the test is not the fact that you can't solve it. That's not bad at all. It's that you would be stubborn and try to solve it when it's too hard for you. That's the thing you want to avoid. Because it is a hard question. So you can do very well in the GMAT without answering this question correctly. But you can't do well in the GMAT if you're going to waste your time on a question like this. So that's really an important takeaway. And the other takeaway is if you want to be able to make such inferences in a timely manner, then you have to keep practicing making inferences, and that's how you get faster. But the way to get faster is not to speed read through the question and then try to work some kind of miracle in the statements. Okay, so we get to the question itself. It's asking, what is the average of all 20 amounts on a spreadsheet? What is the average of all 20 amounts on a spreadsheet? Now, if you knew the sum of each row, I'm not looking at the statements yet, by the way. I'm just asking you, if you knew the sum of each row, do you think you'd be able to figure out the entire sum of the whole, all 20 cells? Look at the drawing that you made on your paper. If you knew the sum of each row, how would you go from that to the total sum? What would you do?
I mean, just add up the rows, the row totals?
That's it. That's how you do it. You just add up the sum of the sums of the different rows. That would give you the total sum. And what if you had the sum of each column? Then could you find the total sum of the 20 cells?
It's the same.
Same thing. You just add up the sums of the columns, and that would give you the sum of all 20 amounts. So before we even go to the statements, we can say the following. If I know the sum of all the RIs, R1 plus R2 plus R3 plus R4 plus R5, if I knew that, that would be sufficient. And same goes for if I knew the sum of the C's. And then if you've done that, if you've rephrased the question in that manner, how long do you think it would take to then evaluate the statements and determine whether they're sufficient or not? If we knew the sum of the rows, that would be sufficient. And if we knew the sum of the columns, that would also be sufficient. So then how long does it take to evaluate the statements at this point? The statements, statement 1 gives us the sum of the rows, and statement 2 gives us the sum of the columns. So each statement is sufficient on its own. What that means is that if I do a good job before getting to the statements, then evaluating the statements is a matter of just a few seconds. Which means I can take the full 2 minutes before even evaluating the statements.
In general, Avi, for data sufficiency, you would say that, right?
Certainly if there is a bunch of free info. Not every data sufficiency question has free info. But in this case, if I were to highlight the free info, let's see how much highlighting I would have to do to highlight all the free info. I would have to highlight everything up to the word what. All of this green stuff is free info. The question starts at the word what. So as a rule of thumb, the more free info they provide, the more work we should be doing before evaluating the statements. It's similar in that sense to critical reasoning, where you want to do all of your work before you read the answer choices and then just read them at the very end of your 2 minutes. Now there is one more thing that I want to highlight here. When you look at the statements themselves, does anyone notice a curious relationship that looks like some kind of coincidence between the statements? If you look at these two numbers, in the context of these two numbers, what stands out to me is that they have the same ratio. They both have a ratio of 5 to 4. You have 5/4 as many rows as you have columns, and it just so happens that the sum of the rows is 5/4 the sum of the columns. I shouldn't say that. The sum of the averages of the rows is 5/4 the sum of the averages of the columns. That's too big of a coincidence to be just a coincidence. This is like if I knew nothing and understood nothing about this question, just noticing that coincidence, I would say the following, and I would be fairly confident about this. Not 100% confident, but fairly confident that these statements look like they are probably inferentially equivalent. Meaning, if you know statement 1, you can infer statement 2, and vice versa. If you know statement 2, you can infer statement 1. I can't prove that without really understanding what the question is asking. And if I do really understand what the question is asking, then I can just solve it. I don't need to worry about these kinds of guessing strategies. But it's a pretty big coincidence. The fact that you have 5 rows and 4 columns, and it just so happens that the statements have a ratio of 5 to 4. So I'm fairly confident they're inferentially equivalent. And who remembers which answer choices we can eliminate in data sufficiency when the statements imply one another? Exactly. A, B, C are all gone, and you're down to a 50-50 shot. So that's a guess. It would be a guessing strategy. But it's a pretty educated guess. It's a pretty solid guess. It's going to be either D or E. And I explain the reasoning behind why ABC can be eliminated in section 2 of the book, which is all about data sufficiency.
The wrong inference here is to say that each of the totals is 110, right? That's a wrong inference, correct?
Yes, that's a wrong inference because
this is an average.
Yeah, so let's remind ourselves. So we said that 4R1 is the sum of row 1. If you were to say this, then you'd get the sum, because you're adding up all of the sums of the rows. The sum of row 1 is 4R1, the sum of row 2 is 4R2, and so on. So if we know that this amount here in the parentheses is 550, then the sum total is 4 times 550, which is 2200. When a daunting looking question pops up on the screen, what do? and your reaction was to just guess and move on. It's not a terrible reaction to have, to be clear, especially if you are worried about running out of time. It's not a bad reaction to have. I would prefer the following reaction. I mean, so this is my philosophy on GMAT questions. Some questions look easy and are actually hard, and some questions look hard and are actually easy. So rather than make a judgment call, rather than judge a book by its cover, if I were to use that metaphor, I'll allow myself something like 2 minutes to try any question. Now, if I can establish in the first 40 seconds that it's too hard for me, great. I get to save 1 minute and 20. If a question looks really easy, but then at around the 2-minute mark I realize that I'm still not close to an answer, then similarly, I'll just cut my losses and guess and move on. So in other words, I don't decide one way or the other just based on how it looks. I give every question a fair shake, and in some cases I can establish really quickly that the question is too hard for me. I had one many years ago on the actual GMAT that was like that. Within 12 seconds, just started giggling like a schoolgirl, and thinking, yeah, there's no way that I can solve this in 2 minutes, and so I just guessed and move on, right? And that's great. That's perfectly fine to do. But I still gave it a chance. I still read it and thought about it for a few seconds. It just so happened that I very quickly knew that it was too hard. So you need a certain level of humility to be able to admit defeat, but you don't want to admit defeat too soon. You don't want to not even give the question a chance. So that would be my advice on that. And vice versa. Just because a question looks easy doesn't mean that it is. And so if I spend about 2 minutes and I'm nowhere near, move on. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.